Hi, in this video we'll talk about data migration using transportable tablespace with incremental backup. With incremental backup procedure, we can migrate tablespaces of any size with very minimal downtime. Say for example, we have to migrate the tablespaces or we have to migrate the data from Solaris to Linux and the data is of 1 terabyte. The approach that will be used with the incremental backup procedure is we first take the level 0 backup of the tablespace data at the source, SCP to the target, restore it at the target. If the Indianness is different, the conversion will also be done and restored. And then we take the incremental backup of the data. Then the incremental backup is also SCP to the target side. It is restored and applied on top of the level 0 backup data files. So we can follow the same incremental backup procedure till the time we want to do the actual cutover operation. And during the time of cutover operation, we just keep the table spaces that we are migrating into read-only mode. Now we take the final incremental backup along with the metadata of the table spaces. We take the metadata and the final incremental backup. The final incremental backup is SCP'd to the target and it is applied. And we make use of this metadata and do the metadata import on the target side. Now the table space has got all the data and the database has even got the metadata of this table space, and the table space is available in read only mode and we can just convert the table space into read write mode. So the only downtime required here is from the time we keep the table space in the read only mode. So even if it is 1 terabyte, we just need to keep the table space in read-only mode only for few minutes. So this way, using this approach, we can migrate data of any size with minimal downtime. If we have to compare this with the previous method, to migrate 1 terabyte tablespace data from Solaris to Linux, we will have to keep the table space in read-only mode. Then we will take the metadata dump of the table space. Then we copy the data files from source to target. And if the Indian format is different, we'll have to do the conversion. And once the converted data files are available on the target side, then we do the metadata import on the target side. Once both the data files and the metadata of the table space are available, then the table space is accessible in read-only mode and we can convert into read-write mode. So during this entire operation, the source is in a read-only mode and this could take multiple hours. In contrast, with this new approach, incremental backup approach, the table space is in read-only mode for very little time. Please note, the limitations of the transportable table space apply even for this procedure as well. We need to ensure that the source and target are making use of the compatible character set and a national character set. Also, the source version should be less than or equal to the target's version, and the source compatibility parameter should be less than or equal to the target's compatibility parameter. So we can use this approach as an upgrade method also. If we want to upgrade the data from 12C to 19C, we can use this technique. Okay, moving further, to use this approach, we need to make use of this script provided by Oracle. And this has two important scripts. We will discuss them in a little bit. And this procedure does not support Windows either as the source or the target. and this works only with Enterprise Edition. And the source DB compatible parameter must be same or less than the destination DB compatible parameter. And the source DB must be in arclog mode. Regarding the Armin considerations, we cannot use compressed backup, and the source side the backup should be uncompressed, and we need to make use of the backup type to backup set, not as backup type to copy. And we can only make use of disk based channels, and we cannot have any channel configurations like max piece size or max set size. And this is meant for table spaces with the read write mode. Source Oracle version should be lesser than or equal to the target's Oracle version. And source and target must have a compatible character set and a national character set. And this approach is used for any databases with versions greater than 11.203 and till version 19.18. This approach can be used for both ASM and non-ASM. ASM can only be used as the final location for the data files, not for storing the backups. And backup location and destination should be read-write, as a conversion of Indian format may be required. And all steps in this procedure are run as Oracle user, and it makes use of OS authentication to connect to the source and target database. And no data files should be dropped from the table spaces being migrated once we start the migration. Although we can add new data files on the source if required during the migration, and this migration procedure completely takes care of them. Although not recommended, a standby DB can be used for this procedure, and we'll have to follow this document for that. A snapshot standby is not supported for this procedure. And if the source DB is 12C or higher, then we will have to set this parameter, use arm transport in the xtt.properties. We will see about this thing in a little bit. On the target mission, we install the required Oracle software and create the database. Once we have the software and the database on the target side, we also need to create the user who holds the objects on the source side. So we'll have to create that user manually. So once we copy the script to our server, we need to unzip it. And once we unzip, we have this file xtt.properties. In this file, we need to set a few of the mandatory parameters. We need to specify the table space that we want to migrate, and platform ID. This is the platform ID of the source. Using this command, we can get the platform ID of our source. And on the source side, where do we want to take the backups? We need to specify that location using this source scratch location. And on the target side, where do we want to copy the backups from the source to the target? We want to specify that location using the destination scratch location. And the dest data file location, this location specifies the location where we want the database files to be restored in the target side. And user arm transport is equal to 1. If our source database is 12C or higher, we need to uncomment this. And irrespective of our target version, we need to match this parameter on the target also with our source. So if it is 12C or higher, we need to uncomment this parameter in the xtt.properties file. And after making all these modifications on the source, we just copy all these files from source to the target side. So before we start this procedure, I just want to give a high level overview of it. So we copied the script file, we unzipped it, we edited the parameters. And once we edit the parameters, we need to set this location where we copied the script with the temp directory on both the source and the target. So wherever we copied the scripts, we need to specify that location as temp directory. And once we set this thing on both the source and target to initiate the level 0 backup, we can run the script Oracle home perl bin perl xtt driver.pl -backup. So this thing takes the level 0 backup now. And once the backup is completed, we need to SCP it to the target side. If we can get a file system that can be mounted on both the source and target, We can save the time for SCP also. In my case, I am doing the SCP to the target site. Along with the backup, we also need to take care of this file, res.txt. We need to SCP that file also from source to target, and from temp directory location, that is wherever the location these files are available, we need to copy this res.txt from source to target site. And once we copy the level 0 backup along with the res.txt file, then we need to initiate the restore operation on the target side. And again, the command for the restore is the same thing. Oracle home perl bin perl xttdriver.pl -restore. Since we have already set the xtt.properties, the location where the backup is available on the target side and where the restored data file should be written on the target side, this process automatically understands where to look for the backup and where to write the restored data files on the target side. We have set those locations using these parameters: dest scratch location to identify the location for backup, and dest data file location where the restored data file should be returned to in the destination. Once this thing is done, it restores the level 0 backup on the target side. Please note, till this activity, the table space is still in read-write mode on the source side. This could take multiple hours, but the table space on the source side is read-writable. And once we take the level 0 backup, we can go for incremental backup. Just to imitate some load after the level 0 backup is completed, I have created a sample table and inserted some data into the sample table. So once this sample table is created and some dummy data is loaded into it, then I will take a incremental backup at the source side. And again, the command for the incremental backup is the same thing. Oracle home perl bin perl xttdriver.pl. We are invoking the xttdriver.pl script with the backup flag and debug messaging. Once the incremental backup is done, that is, it will take the backup from where the level 0 backup is completed. From that point, it will take the level 1 backup. Now we can ship this level 1 backup to the target side. Along with the level 1 backup, we also need to copy the res.txt file to the target side. And once we have both these files, we'll have to do the restore operation, so that the data files on the target side will get the latest changes applied. And the command for the restore operation is again the same thing. Oracle home perl bin perl xttdriver.pl -restore, and with the debug flag. And debug is just for the sake of messaging. And we can do this incremental backup and restore any number of times as required for our use case. And once we are ready to do the final cutover, we will have to take the final backup. And before that, we will have to put the table space on the source database in read-only mode. So now we place the table space in read-only mode and do the final backup. The only difference here is we make use of this flag bkp export. So it takes the incremental backup of your data files, and along with it, it even performs the metadata dump of your table space metadata. So it does both the things. This command oracle home perl bin perl xttdriver.pl -bkp export. It takes the final incremental backup of your table space, and it even takes the metadata dump of your table space. During this final incremental backup, we get this warning and it can be ignored. Once we have the final incremental backup and the metadata dump, we'll have to SCP them to the target side, along with few other additional files like xttplan, tsbkup, map.txt, and other files. Once we copy all the files to the target site, we do the restore operation. So the restore operation applies the data from the final incremental backup to the database files. And the flag that we need to make use is --res incr dmp for the xttdriver.pl script for the restore operation. And once the restore operation is completed, now the tablespace data files are in sync with the source. And this step even restores the export dump file or the dump file of the metadata for the tablespace. And using that dump file, we will have to run the impdp command. Impdp, the dump file that is restored by this command. And we need to copy the dump file to a directory, specify the directory name, and transport data files. Whatever the tablespaces data files that were restored in this operation, we need to name that. If we have many, we can use the pair file and the log file for this operation. Once we do this, it even imports the metadata of the tablespace on the target side. Now on the target side, it has the data files and it has the metadata. And the tablespace is available in read-only mode now. Please note, this operation, as we already know, does not copy the sequences, views, procedures, triggers, or other objects which are stored in the system tablespace or in the metadata. We will have to copy them manually. Just how we copied the user or how we created the user on the target side, same way we will have to copy these things. And once everything is in place, we can convert the tablespace into a read-write mode. So to imitate a real-world scenario, we will take the level 0 backup on the source side, ship it to the target, restore it on the target side. And after the level 0 backup is restored on the target side, we perform some load on the source side. Like we create a dummy table and add some data into it. Now we take a level 1 backup and ship it to the target side and restore the L1 backup on the target side. Again, before we do the final restore, we add some more data on source side, 5 more records on source side, and then now we place the tablespace in read-only mode on the source side, take the final incremental backup and metadata dump. Along with other files, we ship these things on the target side. We apply the final incremental backup and plug this metadata in the target side. Now the tablespace is available in read-only mode on the target side. If required, we will have to create the sequences, views, procedures, triggers on the target side and ensure that we have all the other objects which are there in our source in our target also. Once we are happy, then we convert this tablespace into read-write mode. So this is the process that we are going to do. So moving to the practical, the blue is my Solaris mission and the black is my Oracle Linux mission. On the source mission, I have copied this zip file required for performing this activity, and I unzipped into a XTT directory in the home directory. These are the files that I got after unzipping. And xtt.properties. Here we need to specify the parameter values like the table spaces that we are migrating, the location where we want to take the backup on the source side, and the location where the script looks for the backups on the target side, and the destination data files location. I set up all these parameters, table space as users, and the platform ID for Solaris is 20. And for the source scratch location, I am making use of the /backup source backup. And the destination data file location, I want my destination data files to be restored to this location. And the destination scratch location, on the destination side, the script should look up for the backups at this location, /backup/tgt_backup. So I SCP'd all these files to the target mission. And in the target mission, under the home directory, I have a directory by name XTT. So all these files are SCP'd to this location. We need to set the temp directory on both the source and the target. So the scripts are available in this location. So I set the temp directory here. And on the target side, the scripts are available on this location. So I set the temp directory here. On the source side, let's do a level 0 backup of our table space. Users is the table space that we are planning to migrate from our source to the target side. So we are taking a level 0 backup of the table space users using this command. It completed the backup. Now the level 0 backup should be available under /backup src backup on the source. This is the level 0 backup for the table space, and the res.txt file should be available under the temp directory, res.txt file. So we need to SCP both of them to the target side. We are SCPing the level 0 backup to the target location. And we need to SCP res.txt also from source temp directory to the target temp directory. My level 0 backup is copied. And my res.txt is also copied. Now we can do the initial restore of the table space. And for that, we can use this command. So xtt driver.pl restore. It completed the level 0 restore of the table space. Now we should be able to see this data file on the target side. Data file is available now. Let's imitate some load on our source side. And for that, we are going to create this table and load this data into the source side. I created the table under the schema HR. And I loaded 10 records into the sample employees table. Now let's do a incremental backup at our source. And we can make use of this command, xtt driver.pl --backup. and the incremental backup for the table space completed fine now. We need to ship the incremental backup and rest.txt to the destination. So we can SCP the incremental backup using this command. We even need to ship the rest.txt. Now on the target side, we have the incremental backup. And we have the rest.txt copied. And now we can do the incremental restore using this command. Oracle home perl bin perl xttdriver.pl -- restore. It restored the incremental backup on the target side now. Before we proceed further and take the final incremental backup at the source, the objects in the user's tablespace are owned by user HR in the source. So we need to create this user HR on the target side manually and grant him the required privileges. Now the user who owns these objects and the source side is created manually on our target side. We can go ahead and create the procedures, functions, triggers, views at this time also. But let's proceed and take the final incremental backup on our source side. But before we do the final incremental backup, let's run this DML to imitate some load. So 5 rows inserted on our source. Now we can place the table space in read-only mode and do the final incremental backup using the special flag BKP export. You are placing the table space into read-only mode now. So this command took the metadata dump of the table space and performed the final incremental backup of the table space. And this warning can be safely ignored. Now let's ship this incremental backup to the target. Along with the incremental backup, we even need to SCP these files as well. We need to SCP this file as well from the source and the destination. We can run this command res incrdmp. This command applies the final incremental backup to the data files and also restores the metadata dump from the backup set. So it applied the final incremental backup and it even restored the dump file from the backup set. This holds the metadata for the table space. So we need to copy this to our directory. This is my directory object location. I am copying the metadata dump to this location. We need to import the metadata into the target database. So impdp dump file, the dump file name that it just gave. And I copied this to the directory dpump and the transport data files. This is the name of the data files that was restored, and log file name. So let's run the metadata import now. So it imported the metadata as well. I had an error about 2 triggers. So please note that the triggers will not be copied using the transportable tablespace. We will have to copy the triggers manually. We will do that. And this is for the ORDCs. We can safely ignore this for now. So let's check the status of the tablespace on the target side. It is in read-only mode. We can verify the object count and compare the object count of the objects in users tablespace in source and the target. And if there are any missing objects, we can create them on the target side. Okay, let's verify if we have received all the data. We have created this sample.employees after our L0 backup. And we inserted 10 records after our L0 backup. And just before the final cutover, we inserted these 5 records. So we have got all the data from our source to the target database. Let's verify the object count now. On the source side, this user HR has got 37 objects. And on the target side, this user has got 31 objects. Let's get the object count by object name. We don't have the procedure, sequence, and view on our target side. So let's copy them. I copied all the objects onto the target side and ensured that there are no invalid objects on the target side. Please note, I have skipped the steps of verifying if the table space is self-contained on the source and if the source and the target character set and national character sets are compatible, and all other pre-checks. I have skipped them. And if you want to understand more details about it, please watch my previous video. I will share the link of it in the description. And that completes the activity of data migration using transportable tablespace with incremental backup and with minimal downtime. Thank you.